Hello and welcome to my channel. Today I'm going to be starting a series on how to build a basic project box for an Arduino UNO. I'll be covering how to design the box as well as test the alignment for the posts and the USB openings. I will also be covering how to use the Spreadsheet Workbench and aliases to set values in your drawings. The version of FreeCAD I'll be using is FreeCAD 0.17, the daily build, built on June 13th, 2017. To get started, we're going to create a new document, and using the part design workbench, we're going to add a new part and a new body. And then to that body, we're going to add a sketch. The sketch will be in the XY plane, and click OK. And then we're just going to add a rectangle to the sketch. This rectangle is going to be a bounding box for the Arduino UNO, so we're going to set its dimensions accordingly. So the Arduino UNO is measured in imperial units generally, so we're going to be using a drawing to get those measurements. The first measurement I'll add is the Y dimension, so I'm going to select that, and then let's move over to our drawing. So you can see here our drawing of the Arduino UNO is in mils, so that's thousandths of an inch. You can see that defined here, and the outside dimensions are given right in this text. Although you could also deduce that from these values here. So it's 2700 by 2100. So we're going to enter them in mils, and FreeCAD will interpret those for us. So you can do 2100 mil. And then just click OK, and you'll see that FreeCAD has adjusted it to millimeters. So we'll do the same thing for the horizontal or the X dimension here, and that was 2700 mils. Now I found that these dimensions aren't exact for my UNO, but I think they'll be close enough for most that you'll be able to use them, and then if you need to adjust them in a tiny amount, you'll have to do so. So you'll see that it's adjusted to millimeters for us, which is useful. And then now we're just going to finish the constraining of this by doing two symmetry constraints, one on the horizontal and one on the vertical. And then this sketch is done. Now this sketch is really going to only be used for reference, and it helps us to know where our Arduino is. After I finish constraining this sketch, I want to rename it so that it's easier to identify. So I'm going to call it Arduino Outline. The next step in creating our project box is to add a sketch that defines the outer edge. To do that, I've created a spreadsheet using the Spreadsheet Workbench. You can see the Spreadsheet Workbench is here. And I've given some labels and aliases. So for the aliases, I just entered the value, and then in the Spreadsheet Workbench, you select the cell you want to change and click Alias, and then just type the alias in. So you see I've created nozzle sizes, wall thickness, UNO length, UNO width, and offset from board. You can also right-click on this, click Properties, and select Alias, and enter it there as well. The effect is the same. So we're going to use some of these aliases in the next drawing, wall thickness and offset from board. So we'll need to change back to part design. We'll need to select the drawing in our tab here, and with the body active, which it is, we can create a new sketch. We're going to put that on the XY plane and click OK. And to the sketch we'll add a rectangle. To constrain the lengths, I'm going to select the corner here and external geometry to the Arduino board. Now it's not recommended to use external geometries unless you have to, and I'll show you a way to get around that. So next we're going to add the formula for this constraint. To add the formula, you click on the function of X icon and start typing spreadsheet, and you can down arrow to select that, and we're going to do wall thickness, and it's plus a spreadsheet again. In this case it doesn't do the intelligent select, and this one is board offset. Now you know you've typed it correctly because you've gotten a result back, and click OK. Click OK again. And you see our value is updated. To do the second one, we're going to do it a little different. I'm going to select that external geometry again, and we're going to add a constraint that way. But instead of doing it here, I'm going to show you how to do it outside of the sketch. Now we'll need to go back in our sketch and finish constraining this. So I'm going to be selecting the two endpoints and the middle line and doing a symmetry. And then I'll do the same thing on this, on the vertical as well. I'll do symmetry. So now you can see our sketch is fully constrained. If you wanted to eliminate this external geometry, which I recommend, what you can do is you can select this point and the center point and do a horizontal constraint, and you'll get your resultant measurement. Now this won't get updated by the spreadsheet, although you could put in another formula that's a little more complicated. So with our sketch fully constrained, we can close this and move. Let's rename it real quick, and we'll say we'll do project box outer. Let's change it to project, and that sketch is complete. The next thing we'll be doing is padding this sketch. So to pad the sketch, you simply, with the sketch selected, you select pad, and we're going to leave it at 10 millimeters for now. With the pad completed, we're going to create a sketch to remove the inner portion of the case. So I'm going to select the upper surface of the pad and add a sketch to it. Now I want to note here that developers have been switching to using datum planes to attach, but I found in smaller drawings it's not too difficult to manage with just attaching it to the surface. So in order to constrain this, we're going to move back to the model and we're going to hide this pad so we can easily see the Arduino outline, and we're going to add the external geometry. So if I add the pad back, you will see that the geometry comes through, which is a nice feature. So I'm going to select these two corners and do a horizontal constraint, and we're going to add just the board offset to this formula. I'm going to select the icon f of x, and we're going to do spreadsheet and board offset. So when it's just one parameter, it's really easy. So with that constraint selected, we're going to add a constraint here, but we're going to modify that constraint outside like we did before. So the final thing we're going to do is add symmetry. And we'll add symmetry here as well. And that fully constrains our sketch. You'll notice it's too big right now, but when we change it, it'll be okay. So now we're going to close the sketch. We'll select it here and go down to our constraints. And I'm going to copy the constraint and paste it here. Oops, try that again. And you'll see it updated the sketch. So that's part of how to do parametric. So now the next thing we'll do is we're going to pad this down in, we're going to pocket this down into the pad. To create the pocket, select the sketch we just created and then click the pocket icon. We're going to leave this at 5 as we'll be completing the depth with a formula. To create the formula, select the pocket and then in the length field select the function icon. We'll be using values from the spreadsheet. So type in, first we'll add the pad length, so type in pad and then period and length. You can select it from the drop down list and you can see it's already got the 11 millimeter result, which is the length of this pad. So from that length we're going to subtract the wall thickness in the spreadsheet. And that alias is here, and it was wall thickness. I think it's a capital T. Right. So now you see the result is 9.4. So that'll give us a more robust solution that as this pad changes, this pocket will change accordingly. So you'll notice that I've now got an error introduced into the pad formula, and that's a bug in FreeCAD. And the solution for that is, and what the problem is that this alias here doesn't specify a unit. Even though it's displaying with millimeters, the actual value doesn't have a unit, and that's because I can't enter a unit there on that formula. And the fix is sort of I guess a typecasting, and you can see the fix down in here is I multiplied wall thickness times 1 millimeter, so to infer the unit. So that's fixed on this one. You see it gives me a proper result, and now I'm going to fix it on this one so you can see that in action. So I multiply the wall thickness, so that's the one I can't have a unit on, times 1, and that fixes that error there, and it should propagate up. Yeah, so that fixes our error. So that's a little extra little workaround included with the video. Now that the pocket is complete, you can see how our formula is valuable. I'll change the size of the pad, and you'll see that only the walls change and the floor stays at the correct distance for printing. So let's move that back to 11, and now we'll move on to adding the lip ledge. Adding the lip ledge, or the ledge that will receive the lid, or lid lip I guess I called it, is similar to adding the pocket. So I'm going to select the same plane and add a sketch to it. I'm going to create a rectangle and constrain it much the same way I did before, using the Arduino outline, and we'll hide the pocket. We're going to create external geometries here, and we'll create a constraint this way. And in this case, it's just going to be simply, I think, just wall thickness. So let's look that up in the spreadsheet to find out. So the measurements we're going to use are from the spreadsheet. It's going to be wall thickness, and that's going to be divided by 2. And because of, actually I'll add that later, then it's going to be plus spreadsheet and board offset. Now that's going to be incompatible like before, so we can just multiply this by 1 millimeter to do a typecast sort of fix. So that's our setting there, and then we'll do the same thing for this guy. And I'm just going to change this right. Now you notice I don't have to leave the sketch to make this change. So I can edit this. Now depending on your version of FreeCAD, you may not have to do the 1 millimeter fix. This was a bug that I think was introduced in somewhere along the point in 0.17. So finally for this sketch, all we have to do is add a symmetry constraint in both directions, just like before. So this process just repeats a couple of times for these alignment things. And let's close the sketch to see if we got it right. So you see that ledge is halfway between these two. So now we're just going to pocket it. And in this case, I'm just going to pocket it 3 millimeters. I'm not going to make that parametric. Now that pocket will follow the top. So if I change this pad, that pocket should follow along. Yep. So that would be a little bit too much, I guess. And let's put it higher. And you see that follow along nicely. So you see this still works. We don't need datum planes yet. So I think as long as the items aren't too complex, you shouldn't need datum planes, but you can't take that to the bank. With the basic shape of the project box complete, we'll add post mounts for the Arduino on the bottom of the case. We'll select the bottom of the case, and with that face selected, we'll add a sketch. On this sketch, we'll add 8 circles. So to create the post mounts, we'll add 2 circles in each corner. They'll share the centers, so that'll create a wall for each post. So we'll do that in each corner. And after we've created the four circles, we'll set the radius. To set the radius, we'll select all 4 inner circles click the radius constraint. We'll share all the constraints, and the value will be 1.5 millimeters. To set the radius for the outer circles, we'll select all four and select the radius constraint. We'll share the value and we'll set that to 3 millimeters. To set the position of each of these posts, we're going to be using a different drawing, and this drawing shows the dimensions of each post in relationship to each other, and that's pictured here, and you can get it from this link, and I'll put that in the show notes there. So the way this works is that we move around the whole object, constraining each post to each other. So the difference in length between those two post centers is 1.27 millimeters. And then we can do the next one is from here to here, and that's going to be 50.8 millimeters. And I do from here to here. Or, nope, I'm sorry, I'm going to do from here. So we're just basically going around the square, setting all the offsets from each other. And you see how it's just going to push each post into the correct position. And then finally, so that's 27.94. And then this one is offset from here. And that measurement is 5.08. I had to look down for that one. And then finally it's the distance from here to this point. So we're just kind of going around in a circle or a square. So then the final, so now they're constrained to each other. You see how they all move in. So the final one is the distance from this corner to the corner of the Arduino. So we need to bring the Arduino outline. So another way to get an external geometry instead of hiding is you can just rotate. So there's my Arduino external geometry, and I can select it, and then it'll show through to the working plane. So now all I have to do is set these final distances. So the distance from this post to the edge of the Arduino is 3.97. And then this post to the edge of the Arduino in this direction is 2.54. And you see now our posts are fully constrained. Once our post sketch is complete, we're going to add a height of the posts in the spreadsheet. And this is so that we can easily change the height of the posts. So I've added a variable or a spreadsheet entry here for post height of 3 millimeters, and I'll use that when I'm creating the pad of the post for the post. So we'll move back to the drawing and we'll close this sketch and we'll pad this sketch, and in the pad value we'll go to spreadsheet and select post height. So that will allow us to move the posts up and down as needed. I selected 3 millimeters so I had plenty of clearance for the soldering tabs underneath. The very last thing we'll do to this case is add fillets. So what I have found is to get larger fillets on the outer corners, you should do the inner corners first, because I want a 3 millimeter fillet on this, and if I don't do these first, that makes the outer fillet, if I did the outer fillet first, it would try to be inside this corner, which would make it invalid, and FreeCAD won't let you do that. So I selected one line segment to start my fillet, and it adds it with a 1 millimeter, which is what I'm going to use. And then I'm just going to do add ref to each of these corners. And once I'm done with the, so I mistakenly selected the face, so we're going to do remove ref, and then do add ref. And so that's our internal fillet. And now I'm going to do this fillet. I'm going to select one of these. This is going to be a 2 millimeter fillet. It might not be the exact correct value, but that gives it a little bit of continuity around the corner. And I'll show you at the end. So now I'm going to add each corner as a reference. Now you can actually select all of them at once before doing the fillet, but I find I do a lot of misselections then, and I get the job done better this way. So that's a 2mm fillet, and then on the outside we're going to do a 3mm fillet. So I'll show you that you can select, using the control key, you can pre-select the segments you want. Okay, so now I'm going to add the fillet for that, and that's going to be 3. And then on the bottom I've filleted this before, but I found that when I print it, it just comes out as an angled line. So this time around I'm going to try it just flat and see if I like that. So in the pictures I'm going to show you soon, you'll see this bottom corner rounded, and you can do that. You can actually, I'll just show you real quick. If you select the whole face and then just add a fillet, you'll see it adds it all the way around, and you can make that as big as you like. And actually that's probably going to be invalid because that line's poking through. So you could fillet that if you want. Actually I just will. So that's our finished model. So the next thing we're going to do is we're going to go into the TechDraw, and what we're going to do in TechDraw is to get drawings to make sure our measurements came out well. Now that our project box is complete, we're going to go over into the tech drawing workbench to make some drawings. You can select the tech drawing this way, and these two icons, sometimes they show up over here, sometimes over here. I don't know why. So I'm going to insert a new drawing, and you'll see it's scaled to A4, which is good if that's your printer. Mine's not. Mine's a I'm in the US, so I need a US. Unfortunately, there's no templates for US. So what I did was I created one in Inkscape, and I put it in the template directory. What you can do then is go into this template, and you can see that this is where it's stored. Thank you, developers, for listing the directory. That helped a lot. And I can select the directory and then pick the 8x5 I made. I don't think that template is perfect, but it works well enough for me. And why it's important to have the correct size paper, I don't want my printer resizing anything because I'm going to use this to test my drawing. So now what you do is you select the final item or final feature in your drawing, and you add that to, I've lost, this got moved too. So, and you add that to your drawing. We're just going to do the one part, and some drawings I'm able to slide it. So before I'm not always able to move that for some reason. So now I do want an end view of that, and just to show you the feature, I'm going to show you the, let's see, where was it? I'm going to show you how to do a section view. Okay, so it's using this section view icon here, and you just click that, and then it asks you what section view you want. And for me, it doesn't matter. I just want the USB port and the power port, so I'm going to be doing this direction. So I'm going to pick this, and you see it's put our section view in there, and that's good enough. So now I really don't need the cross-section view. I just needed the openings, but this certainly doesn't hurt to know this. I could test the post measurements too and stuff like that. But what I need to do is print this out, and I'm going to be holding my Arduino right up to it to see how close I am. And one of the things that I do know is that these lines are too thick for that. So what I'm going to do is I'm going to go into the section view, and I'm going to change the line width just to half of what it is here. So now when I print it out, I can see a little bit better if the Arduino lines up. And I'm going to do that to this as well. So I'm going to change the line width to 0.35. And then, so now I can just print this. So I would just go in File, Print, and it's going to print. I'll do a print preview. So it's going to print your drawing page. Very useful, and I have to thank Ben Heck for saying, test it with a print piece of paper instead of printing. So next I'm going to show you some photos of the Arduino aligned with this, and how you can tell if your drawing is accurate. So here I've printed my final output, and for the first test of this case, and I was pretty happy with the output. Although I found that by printing this calibration piece, which was overly engineered, this is supposed to be 110, and mine comes out to 112 point something. So the dimensions on my delta are wrong. So I'm going to have to adjust those before I can get a good printout. But for now, I'm going to show you some pictures of the Arduino lined up with the USB port and with the with these crosshairs. Here I have my Arduino sitting on top of the cross section of the USB port, and you can see that it just fits in there, as well as the power port. And if you look carefully, even into shadow, you can see that the power port is a little misaligned. And I think that was before I did the clearance variable. And here you can see in my final output, you can see the power port and the USB port. Here I have my Arduino sitting on top of the cross section of the USB port, and you can see that it just fits in there, as well as the power port. And if you look carefully, even into shadow, you can see that the power port is a little misaligned. And I think that was before I did the clearance variable. And here you can see in my final output, you can see the power port and the USB port. Next, I'll be showing you a picture of the Arduino laid on top of these holes, and how you can just look through and see if the holes are centered. So here I have a close-up of this UNO, and this is a clone. So this is not an official Arduino, just in case you're wondering. But you can see that the holes are lined up. Don't be confused by this. That's just perspective. But when you look straight down, these crosshairs are directly centered in each of the holes. So I got a really nice alignment there with the Arduino and printing this out first. So here I have pictured the final printout, and although it looks like the power port is misaligned, basically everything in this is shifted by 2% towards this direction. And you can see here that the UNO is not quite sitting in its alignment with the holes. So my printer is adding 2% in the Y direction, and it's a delta, so it's going to be hard for me to troubleshoot. But I believe it's because some of the framing of the delta is not snug, so I'll have to look into that. You'll also note that on this print, this piece right here, you can even see that there's a differentiation between the layers, but that came loose, so I'm going to have to provide some kind of reinforcement or make the walls thicker. And here's a real close-up of that problem on this piece, and I think this had to do with vibration echo. So as you had this opening, the print head was being skewed off, because the rest of the print came out fairly nice. And the final problem that I didn't catch was this opening was too high up, and so the USB port caused the board to lift off of the post. So that's something else I'll have to adjust. But all in all, I was pretty happy with the number of errors being pretty low. So that's it for this first part of the video. In the next video, I'll discuss how I addressed my printer scaling issues, the 2% error on the y-axis, and I'll also try to address. I'm going to try to do the top piece of this, and but I won't be coming up with an interlock method for the lid because I haven't decided how to do that. So hopefully I'll see you next video, and I'm going to try to get it done in a week. So wish me luck, and have a great day.